Hello everyone, and welcome to this new session in which we are going to treat data augmentation. Previously, we had seen how to load our data set from this dataset directory right here, and then we trained a LeNet model which performs very well on the training data but didn't perform as well on the validation data. And then we're able to evaluate this model on different evaluation metrics like the accuracy, top K accuracy, and the confusion metrics. In this session, we are going to focus on data augmentation. That is, we're going to see the effect of augmenting our data artificially without actually getting to add an element in this data set right here, and then seeing how this affects our model performance. Don't forget to subscribe and hit that notification button so you never miss amazing content like this. In this session, we'll see how to augment our data, like those data right here, and see how this technique of data augmentation helps in making the model even more performant. Now, we had looked at data augmentation previously, but if there's one thing you have to note about data augmentation, is simply the fact that it promotes diversity in your data set. And so if you have data like this one here, let's open this. We consider this original data. So this is our original data. This is the data we actually gather. And then we have this brightness here. So we modify this data or this image's brightness, and we obtain this other data point. And then we modify from this, we rotate this, and we obtain this other data point. You see that it's the exact same image which has been modified. And so now the model doesn't only get used to seeing this image right here, but now you could see this one or this one. And so data augmentation is this method or this technique for promoting robustness in models, hence fighting overfitting, as now the model can see different versions of certain data points. So let's close this up and get back to the code here. Let's get back up here. We have data augmentation. We're gonna simply get back to this here. We had data augmentation. We had looked at this already in the previous section, so you could get back and try to understand exactly how this is carried out. Previously, we had seen that we could carry out data augmentation by using this kinds of TensorFlow image methods like this one. You see, you could rotate the image, you could flip left, right, you could adjust the saturation, or you could use Keras layers. Here we're going to use Keras layers. And then also we saw how to use Augmentations library, which is this amazing library which permits us carry out data augmentation on different tasks, not only classification, very easily. So you could check out that video. Now that said, let's simply copy this out here. Then we paste it here. So we have this. We have this augment layers. We have random rotation, random flip, random contrast. Let's actually get back here in this layers and then add the random contrast. So we have random contrast. Okay, so we have that. And you could feel free to get back to the documentation on the TensorFlow Keras layers. Let's get to Keras layers and then check out these different augmentation strategies. Here you can see random brightness, contrast, crop, flip, height, rotation, translation, random width, random zoom. And you could check out the documentations in case you have any doubts. So you could just have this here and you see how to use each and every one of these augmentation strategies. Now getting back to the code, we have this 3 here. Now what was generally done is you could actually run one and then test this or test how it helps in making the model perform better, and then you could add the other and see whether it helps, and so on and so forth. So it's kind of like, it's not a fixed kind of method where you just have some fixed methods or some fixed augmentation strategies which you just place in this order sequentially, and then it will always work magically. Generally, you will have to test this out, test these different strategies out, and then see which one works well for the data you're working with. Now we have this set. Let's run this cell right here. we have this is not defined. Let's get back here and be sure that we run the cell. Let's run the cell. Normally that should be fine. Get back and we run this one here, and that's fine. So we have that, and then now at the level of this dataset preparation, we're gonna include that. We're gonna do the mapping. So we have our augment layers. Note that we're not gonna do this for the validation dataset. We're gonna only do this for the training dataset. We have this augment layers, and then we're gonna specify the number of parallel calls. So we have non-parallel calls, and then this is gotten via the auto tune. So we have that automatically. Then before we move on, we're gonna copy this out here and then simply paste this here. So we create this augment layer which takes this and then it outputs the augmented image and the label. We're not gonna have this here, so let's just take this off. We have just this image. Okay, so that's it. We have this augmented layers, and then we define this function as augment layer. So right here, let's take this one off and run this again. With this, we're now set to train. So let's go ahead and retrain our model. Training is now complete, and we could see that the model doesn't perform as well as it used to do without augmentation. So you see here, with the augmentation, the model performs even poorer as compared to when there was no augmentation. Let's run this here so you could see. I could compare this with the previous results we got, or the previous evaluation. You see, we go from 75% to 54%, and then here we go from 90% to 83%. To understand the reason why we have this drop in performance, let's look at this visualization of our data set. We'll see that after carrying out the rotation, we have images which are rotated at very unusual angles. So you see, like this image here is unusual. This angle too looks very unusual as compared to the kind of data we would have in our test or validation set. So we have to ensure that when carrying out this random operation, we limit the angle at which we could carry out this rotation. So that said, if we have a face like this, or let's say we have an input image like this, we should limit this rotation such that this image cannot be rotated at, say, 180 degrees. So let's have this here so you see that better. We have this, and this. So we do not want this kinds of rotations. What we want is rotations where we have the face a bit tilted like this, and that's it. So we want this kind of rotations, but not this type. So to solve this problem, what we're gonna do is we're gonna get back to the documentation, that's random rotation. We check out this factor right here. We see that the value we put here takes us from negative 20% of 2 pi. Pi here is 180 degrees. Pi is in radians. If we convert this to degrees, we have pi, which is 180 degrees. So we have 2 times 180, which is 360. So when you say 0.2 or negative 0.2, what you're in fact saying is negative 20% of 360. So when you have, let's get back to the code. So when you have your, let's add this cell here. When you have your 0.25, what you're having is 0.25 times 360. Running this, you see you're going 90 degrees. So this means that if you had an image which was already somehow tilted, this image will end up in a very unusual position where the face will look something like this. And so what we'll do here is we are going to limit this rotation. So we're gonna go from 0.025, for example, to this. So let's limit that. We'll go from negative 0.025, meaning that we have here, let's 0.025, that will be 9 degrees. So limiting this to 9 degrees, and then going from negative 0.025 to 0.025 simply means that if you have this axis here and then you have the face like this, let's put the mouth in this, then after rotation you can only go 90 degrees in this direction, or 90 degrees in this, or rather 9 degrees in this direction. So you have a limit, so you can only pick a random value between negative 9 degrees and 9 degrees in this other direction. So you can only go this way 90 degrees or this way 90 degrees. So that said, the extreme, we will have a face like this. That's after rotation. So we'll go from this blue to this red, or you could also get something like this. So this is what we're gonna get after rotation, unlike with the case of 90 degrees, where if you have a face which is already, let's change this, let's delete this. If we have a face which is already, say, tilted like this, you have a face tilted like this, after rotating 90 degrees, what you will have now, let's have here this 90 degrees. What you have now will be a face tilted this way, and this isn't a very usual position when taking an image, so, or when taking a photo. So the images in our validation or our test data set wouldn't look like this, and so that's why we actually limited this here. So let's get back to our code now and we run this. Let's run this training data, and then let's visualize our data set. There we go. As you can see, you do not have images which are upside down as we had before, and that's it. So we have this now. We now go ahead and retrain our model and see what we get. After training for over 20 epochs, here are the results we get. You see that we go up to 78%. So this is the highest we get. And when we run the evaluation, you see here we have this. When we run the evaluation, what we get is 77.8% for the accuracy, and the top K is 91%. So we've improved compared to what we had before, or what we had before the data augmentation. Now we are going to use another data augmentation strategy, which is the CutMix. Now the CutMix isn't like this other data augmentation strategies where we just modify a single image. With the CutMix, as we have seen in the previous sections, we actually combine two images. So what we're going to do here is we're going to simply copy out this code and then put it out in this our code base right here. Now if you haven't, or if you're new to the CutMix data augmentation, you could check out the previous sections where we treat this in detail. So let's get here, and there we go. We're going to apply CutMix and see the effect it has after training our model. So we have data augmentation in here. Let's add the cell and have your CutMix augmentation. Add a code cell, and let's paste out that part of the code. We also paste out this part where we have the training data set 1 and our training data set 2. Then we create this mixed data set. So from here we have augment layer. Let's take this off, and here we have augment layer. So we carry out augmentation for this two separately, and then once we have this two here, we're not going to shuffle. We've done the shuffling already, so we just do the mapping. We do the mapping, and that's what we're saying. Once we have this two here, we're going to combine this into this one mixed data set. So that's it. Let's have that, and then from here now we build our training data set. So let's take this here. Let's take this up. There we go, data set preparation, and then we're now gonna comment this part. So we could comment this one, and we have a validation data set. That's fine, everything looks fine, and that's okay. So we have this set. Let's run this now for our CutMix. You could always try to mix up or the cut out augmentation strategies and see how it better, or how it ameliorates your model performance. So let's have this. Let's run this. There we go. This is our CutMix here, and we combine the two data sets, and then once they combined, we now apply the CutMix augmentation. Here we have this image size not defined. Let's actually, we should have, okay, this should be our configuration. So we should have this configuration. We run this cell now. Run that again, run the CutMix, and we run the cells, and now everything should be fine. So there we go, we have all this fine. And then we get to validation, run that, training data set and validation data sets. Okay, so that's it. Let's go ahead and retrain our model and see what we get. After training for 20 epochs, we notice that unlike previously where the training went to about 99%, while the validation was about 77%, here the training is about 80%, and the validation, let's scroll this way, the validation is about, or the highest we have here is 78%. So this shows us clearly that the model isn't overfitting, because the training and the validation data set both are evolving in a similar manner. So let's scroll down here and look at these curves. You see here, before, look at the accuracy plot. Before, what we had was something like this. We had the training, and here we had 1, and then the validation was like this. But now we have these two curves which are evolving in a similar manner, though sometimes we have these kinds of peaks. Anyway, clearly our model isn't overfitting, so what we'll do is we're going to train for more epochs. So that said, let's go ahead and retrain this model for more epochs. So there we're going to modify the number of epochs. So here we just have to, or what we can do simply is we just keep training. So we train for 20 more epochs. So let's run this and then wait for 20 more epochs. Training now complete. Here are the results we get. As you could see, the validation accuracy starts to stagnate around this, and then after evaluation we obtain an accuracy of 79.71%. But what's interesting to note here is the fact that our training accuracy is still having this value of 86.25%, unlike previously when our model was overfitting, we had this accuracy of about 99%. So that's it. We have that. We've evaluated. We see these values, and then testing on these values here, we see that we have 14 out of 16 images predicted correctly. And here's our conversion metrics right here. See that clearly this model performs best or performs better than all the other previous models.